Hello students, welcome back. The last topic that we are going to discuss in sets and in operations, sets and its operation are De Morgan's law. So we're going to study what De Morgan's law is and how to calculate De Morgan's law. So first of all, we need to know what are the De Morgan's law. Okay, so the first law for De Morgan's law, which is known as De Morgan's law of union, that states A union B whole complement is equals to A complement intersection B complement. Now this is the De Morgan's law for union. Same as we have De Morgan's law of intersection, which states A intersection B whole complement is equals to A complement union B complement. Now, in order to understand De Morgan's law and how it works, we need to take an example, and then we'll see that how these laws are proved. Okay, so let's take an example. Okay, we have a universal set that has elements 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Then we have a set A which has elements 2, 3, 4, 5. We have set B which have elements 1, 4, 6 and 7. Now according to the De Morgan's law, okay, it says that we need to prove De Morgan's law. Okay, what I did here is that first of all I calculated each and every element that is required in order to calculate De Morgan's law. That is that out here, if you can see, we need to know what is A complement, we need to have B complement, we should know how to calculate A union B whole complement and A intersection B whole complement. Now the first thing is that I have calculated out here is A complement or A prime A power C. So how we calculate it? We just subtract values of set of A from the universal set. So as you can see out here, the universal set has members from 1 till 10, whereas set A has members 2, 3, 4 and 5. So after subtracting 2, 3, 4 and 5 from universal set, the final result that I got is 1, 6, 7, 8, 9 and 10. Same as we are going to calculate B complement. Now for B complement, I just subtracted set B, the members of set B, from universal set. So the members of set B are 1, 4, 6 and 7, and if I just subtracted it from universal set, then the elements that I got, the answer that I got is 2, 3, 5, 8, 9 and 10. Now I have calculated, okay, now in order to calculate A union B whole complement, as I told earlier, that we need to solve the bracket first. So inside the bracket we have value A union B. So I've just calculated A union B. So A union B gives me 1, 2, 3, 4, 5, 6 and 7. Okay, if I calculate A intersection B, so the elements that intersecting out here is only 4, as you can see. Okay, great. Now we are first calculating A union B whole complement. Now how to find out A union B whole complement? That is, we just subtract A union B, set of A union B, from the universal set. The result that we got here is element 8, 9 and 10. Same as we will be calculating A intersection B, it is the same that we need to subtract the elements, the answer that we got of A intersection B, we will be subtracting this thing from the universal set. If you just subtract it, as you can, if you remember, the answer for A intersection B is a set with element 4. So in this particular set, the answer that we got is 1, 2, 3, 4 is eliminated, 5, 9. Okay, so out here it's 5, 6, 7, 8, 9, 10. So 5, it's 5, 6, 7. So just place it down here. options. So there has to be 5 and an element 6 also. Okay, so for De Morgan's law of union, it says A union B whole complement is equals to, so just writing except of 6, I have written 9 twice, so apologies for that. If it says De Morgan's law, moving on, it says De Morgan's law of union. De Morgan's law of union means A union B whole complement is equals to A complement intersection B complement. Now taking left hand side first and solving A union B whole complement. Now the answer for A union B whole complement we have calculated earlier. So this is the answer that we calculated. The answer, now taking the right hand side, we have A complement intersection B complement. So now what I did is that I just put it down the answer for that I calculated earlier of A intersection and A complement and B complement, and just I am now taking intersection of these two sets. So the result that I got is set 8, set with element 8, 9, 10. Now you can see that the answer for A union B whole complement and the answer for A complement intersection B complement are both same. So we can say that De Morgan's law of union is proved. Now moving on to the next law, that is De Morgan's law of intersection. Now De Morgan's law of intersection states A intersection B whole complement is equals to A complement union B complement. So taking left hand side first, we're first finding out values of A intersection B whole complement. Now I've calculated these things earlier, so just I am showing you the answer that we first we are going to take A intersection B, then the answer that we got from A intersection B we will subtract it from universal set. This is the final answer that we get. Now out you can see out here, okay, there's the same mistake here, that a part of set C pointer options. Okay, now this is 6. So 1, 2, 3, 5, 6, 7, 8, 9 and 10. Now okay, so moving on, taking right hand side, that is A complement union B complement. I've calculated answers for A complement and B complement earlier, and this is what my final answer is. It says 1, 2, 3, 5, 6, 7, 8, 9 and 10. So as you can see that both sides are proved. We say hence it is proved. I hope that you now had a better understanding of what De Morgan law is and how we prove them.